supplement theorem. Supplement theorem. These are going to be angles that are linear pairs are going to be supplementary. Okay, hopefully that makes sense. Do you see how they make a straight line? Remember, a straight line is how many degrees? 180. So if it's 180, that means it's supplementary. So if angle 1 and angle 2 form a linear pair, I know angle 1 and angle 2 are going to be supplementary. And then if I know they're supplementary, then I know they have to add up to 180. So it like all goes together. All right, again, sorry, there's a lot of definitions and theorems today, so just make a note of that. Okay, last definition is going to be perpendicular lines. That should be familiar, yeah? Okay, so perpendicular lines, from a geometric standpoint, these basically, all you need to remember, they make right angles, okay? What symbol do we use? We use an upside down T. So that's the symbol that we use here. So here we have lines AD and BC are perpendicular. So what can we say about the 4 angles? They're all right angles. And I'm going to put in here forms 4 right angles. Because, why? Well, if this is a right angle, doesn't this on the other side have to be a right angle? And then this one has to be a right angle, and this one has to be a right angle. So they're all right angles here. Because they're perpendicular. So anytime it's going to form 4 right angles here, because this is a linear pair, these are vertical angles. These have to be the same. These have to be the same. Okay, fire. Good luck. All right. Got 10 minutes. We're good on time. Let's see. We want to find the values of x and y so that BE and AD, so BE and AD, we want them to be perpendicular. Okay, so yes. We're going to we want this to be a right angle. Okay, we're going to have 2 different equations. So to solve for y, that whole angle, this whole thing has to be equal to 90. Right? We want this whole thing. So we're going to add. Ooh, this one does not come out nicely, does it? Okay, it's fine. We're going to leave it. Let's see, what can we divide the top and the bottom to make it simplified? We divide the top and bottom by 4. I mean, we can also divide by 2. Yeah. We can divide by 4. So if I divide the top by 4, I get 25 over 3. That's how I prefer the answer. Okay? I don't want you to change this one to a decimal because it's going to be at 3 repeating. And you know how maybe your middle school teacher would let you write the 0.3 with the bar? Don't do that. Just leave it like that. It's actually less work if you think about it. Also, your calculators, again, we'll get to the calculator. It'll reduce it for you. So if you have the calculator that is on your syllabus and the recommended or the required calculator, if you typed in 100 divided by 12, it will give you that answer, which is kind of nice. All right, what do we do for x?
Oh, you just do 9x equals 9.
Okay, so now we have these 2 angles combined, so they're complementary. So I know 6x and 3x has to be 90. Oh, this one works out nicely, right? Good. Any questions there? Last page. Okay. Remember, I think it was yesterday I mentioned don't rely on what the picture looks like. Go by the numbers or the symbols they have in the picture. Okay? So there's certain things that we can assume from a picture, and there's some things that we cannot assume. So for example, HM perpendicular to HL. I mean, it looks kind of close, but we can't assume that unless there's what? The little box inside. Okay, congruent angles, JHK and GHM, these two little ones. They look really close, but is there anything that we can tell for sure that they're congruent? Not if there's, unless we know the numbers or, you know, the markings. What can we assume? Well, we can assume adjacent angles. JHM and MHL. These are adjacent, right? They have common vertex and a common side, but they're completely separate angles. So there's certain things that we can assume, some things that we can't. So let's take a look at this picture. What can be assumed? So KHJ, so I'm talking about this angle, and GHM, are they complementary? No, I mean, could they? Maybe if I knew they were both 45, what can we assume by them? They're congruent. But do we know they're complementary? No. And it's only marked congruent. Okay, GHK, and oh my gosh, GJ. Thank you. JHK. That's the thing in geometry. There's like all these letters, even I get jumbled up sometimes. Are they a linear pair? Wait. Let me highlight it for you.
They share the line.
Okay, here's GHK. Oh. And then JHK. All right. Yes, because are they adjacent to each other? Yes. And do they form a line? Are there non-common sides opposite rays? Yes. So that we can assume. Okay, HL is perpendicular to HM. HL perpendicular to HM. Here's HL, here's HM.
Yeah,
Yes, yeah, there's a little square in there. So, yeah, of course. Perfect. Okay.